and I told you to try 1D, isn't it?
Yes, sir.
And 1D is the drawing. First part you have to draw. Parabi, Parabi,
Yes, sir.
please read part D. Are you seeing the screen?
Yes, sir.
Yeah, read.
Figure 1.2 shows a ray of green light in air striking the side of glass prism. The refractive index of the glass for green light is 1.5. Figure 1.2. Draw the normal for this ray. Mark the angle of incidence with a letter I. Number 2. The angle of incidence is 57 degree. Calculate the angle of refraction of glass.
Okay, before going to number 2, we first try number 1. Okay, how to do number 1? You have to draw, right? Draw the normal. Are you using laptop, Farabi? Hello,
What,
Farabi.
sir?
Are you using
Can you
laptop?
repeat? No, sir. No, sir.
You are using mobile phone. So how can you draw the normal? Where will show the normal? Can you sketch here on the diagram? It's very simple, right, to draw the normal? Hmm?
Yes,
Farabi, you
yes, sir.
have this worksheet printed? No or yes?
No, sir.
No, not yet. So
But
please
tomorrow I will print it.
take the printout as soon as possible. Otherwise, you will miss this drawing part. You cannot do them properly. You see, here normal we should draw, right? Here, huh? Is it clear? How to draw normal? Is it clear to you, Farabi?
Yes.
This way, I'm drawing again, huh? Straight line. Normal is perpendicular with this surface. Monica, are you seeing?
Yes, sir.
Hello, Monica.
Yes, sir.
Did you do this way? Normal.
Yes, sir.
Now you have to draw the angle, right? Angle, how to draw? This way, right? They are saying mark the angle of incidence with the letter I. So it will be your angle of incidence I. And where you drew this normal, you should label it. This is normal. So done. Part 1 is done. Take the snap, huh? Monica, take the snap and send it to group. Now we have next. The angle of incidence is 57 degree. calculate the angle of refraction in the glass. How can you calculate angle of refraction? Farabi? Hello, Farabi. Farabi. Hello.
Yes, sir.
How to calculate angle of refraction? What is the formula? Very simple formula, right? We did in our last topic. What is the formula of refractive index? Hello, Farabi. Monica, how to get angle of refraction?
N is equal to sin I by sin R.
Yeah, that is a refractive index formula, and you should rearrange it, right?
Yes, sir. R is equal to sin inverse in
Hmm.
bracket sin I by R, refractive index.
Sin I by refractive index. Yes, so we will write the formula this way. R equals sin inverse sine inverse R equals sine inverse, then sine,
Sin I,
yeah, sine
just a
I,
second.
sine I divided by n, right?
Yes, yes, sir.
So this formula we should use. Farabi, hello Farabi.
Sir,
Yeah, you got the formula.
sir, sin I is equals to, sir. Sir, I got disconnected.
Yeah, I understood. So look here, the formula for angle of refraction, you write it on your copy, you write it now. Question number 1, D2. R equals sine inverse sine I by n. Then you put the values. What is the value of I? What is the value of I given here? 57, right?
Yes, sir.
And what is the value of refractive index? 1.5. Sine inverse. Okay, then sine 57 degree divided by 1.5. Yeah, Farabi, check what is the answer coming. Farabi, hello Farabi, what's your answer? Have you calculated? Monica?
Yes, sir.
Yeah, what is the answer?
33.9.
33.9. Then you can write 44. Yeah, 34. 34 degree, right?
Yes, sir.
You can give the symbol of degree. In my place, we don't have any, symbol to write here. That's why I'm writing this way. Degrees. 34 degrees. So you have it. The answer we got 34 degrees. Farabi, Farabi, you got the answer also? Have you calculated? Farabi, have you calculated?
Calculated.
Yeah. What is your answer?
34.
34 degrees you got. Or 33.9. What you got in calculator?
33.9.
Yes. Then if you round up, it's coming 34. So done. This part is done. Then Monica send it.
Done, sir.
Now next part. Farabi. Hello Farabi.
Yes, sir.
Yeah, read last part and say the answer.
That's what happens as the light enters the glass to the light's frequency, speed, wavelength.
So what will be your answer about frequency?
The frequency remains the same.
Very good, very good. Then speed,
Speed decreases.
excellent. Then wavelength,
Wavelength
what about wavelength?
decreases.
Decreases, yes. So if it is going to glass, frequency remains same, speed decreases, wavelength also decreases. Why? Why Farabi? Why speed decreases? Monica, any idea why speed decreases?
Because the wavelength decreases, the
Yeah,
speed
first
also
of all,
decreases.
here in this context, we will say that light goes from rarer to denser medium, right? Hello?
Yes, sir.
Light goes from rarer to denser medium. In denser medium, speed decreases. Speed of the light decreases. That's why wavelength decreases. Are you clear?
Yes, sir.
So right. Frequency same, speed decreases, wavelength decreases. And here you write with double star like this, what I said in the explanation. As light travels from rarer to denser medium. This is note, okay? As light travels from rarer to denser medium, speed decreases, hence wavelength decreases. Right now you can see, right? Have you written?
Yes, sir. Yes, sir.
Okay, Farabi, have you written, Farabi?
Yes, sir.
Now we are going to next part. 1D, last part. Yeah, Farabi, read the last part. Farabi, read this last part.
Draw the path taken by the light as it passes through the glass into the air.
Before draw the path, what is written on figure?
On figure 1.2.
So where is your on figure 1.2? You have to find that one. Here, right? So what is written here? What light written here, Farabi?
Green light.
Green light is single color, right? So you write a note here as green light is monochromatic. Monochromatic. Chromatic. Monochromatic means single color. It will not split, but will bend according to its wavelength. Have you written this note? Monica and Farabi, have you written this note?
Yes, sir.
So monochromatic means Farabi also you wrote. Farabi.
Yes, sir.
So it will not split means the way we saw before, you see, in our white light, in our previous diagram we saw like white light is bending into 7 colors, right? Vibgyor. Hello. Hello, Farabi, Monica.
Yes, sir.
White light is bending into white light is splitting into 7 different colors because white light is a mixture of 7 colors.
Yes, sir.
So Green light, it is monochromatic light. It is a single light, right? Monochromatic means single color.
Single.
That's why it will not split, but it will bend according to its wavelength. Here we see the violet is bending most, right?
Yes, sir.
Hello, and red is bending least. So
Mhm.
we have to remember the order. That one we had Vib Gior. Where is G? G is in the middle, right?
Yes, sir.
So here we will show the bending this way. Green is going, then it will not split. There will be a single ray go this way. This way it will go. I am showing you. It will come here, then it will go in the middle. You draw with your pencil, Monica, this way. In the middle, right? Here is green, isn't it?
Yes, sir.
So it will not bend too much or it will not bend less. It will bend in between, right? The green color.
Yes, sir.
So in your diagram, you have to show that one also. Here we have the diagram, you see. So in this diagram, we have to draw the same way we have. Same way you have to draw here, this way. Are you drawing, Monica?
And
This way, bending, there is bending. And after this, we have the bending this way, okay? Is it clear?
yes, sir.
And here you have to give the arrow, huh? Arrow symbol. Okay, this way arrow you give. Is it clear?
Yes, sir.
Farabi. Hello, Farabi. Farabi. Farabi, are you drawing?
Yes, sir.
Yeah, Monica, you take the snap of this part, huh? And send it to group.
Done, sir.
Thank you so much. Now we have question 2. Yeah, Farabi, read question 2.
A laser produces a beam of red light. The red light from the laser has a frequency of 4 into 10 to the power 14 hertz at the speed of light in air.
Yeah, what is the speed of light in air? You have to just memorize it, right? And you know it. In our last topic also we learned it that speed of light in vacuum, it was 3 into 10 to the power 8 meter per second, right?
Yes, sir.
So that one is also speed of light in air. Is it clear? In vacuum and air, same speed. So what should we write here? Hmm? 3 into 10 to the power 8, right?
Yes, sir.
Write it. Write it in your copy. Problem. The touchpad. 10 to the power 8. Are you writing? 3 into 10 to the power 8? Hello? This problem of touchpad. Um, Now let's go. Yeah. 3 into 10 to the power 8, then meter per second. Okay. Now you know this value. You can calculate the wavelength, right? Farabi? Hello? What is the formula? Farabi? What should be the formula to get the wavelength? Farabi? Are you listening? Yeah, Monica. Monica, what is the
V is
formula
equal
to find the wavelength?
speed is equal to frequency multiplied by wavelength.
Then wavelength equals,
Speed divided by frequency.
so we write here wavelength equals wavelength wavelength equals speed by frequency. Wavelength equals speed by frequency. Then our speed already we got. Speed already we got. What is the speed?
3 times 10 to the power 8.
3 times 10 to the power 8. And what is the frequency given?
4.3 times 10 to the power 14.
4.3 into 10 to the power 14. So if you calculate what is coming, the answer, wavelength. Farabi, you also calculate, huh? And check the answer is matching or not. You you also calculate and tell me the answer. What is coming? Speed by frequency equals wavelength. Yeah. So have you got it? 3 into 10 to the power 8, then divided by 4.3 into 10 to the power 14. What is coming?
4 point, no, sorry, 6.97
6.97. Then what is the power?
to the power 10. No, sorry,
Power will
21.
be 10.
21.
How? How is your power? You have here 10 to the power 8. So 3 by, let me check. 3 by 4.3. 3 by 4.3. Then it's coming 0.697. Then your that answer is coming 10 to the power 8 minus 10 to the power 14. That means 10 to the power minus 6. Right? Isn't it?
In calculator, it comes 10 to the power 21.
You wrote somehow mistakenly, like you write when you are dividing, you write bracket here, huh? Bracket, you give bracket, then 4.3 into 10 to the power 14, you close the bracket, then you see what is coming. It should come
Should I
6
use brackets for 3 multiplied
here.
by 10 to the power 8?
Not necessary. This one, the upper one, not necessary, but the lower one is necessary, because if you are not giving bracket, then it is divided by this value and multiplied with this value. But if you are giving bracket, then whole thing is divided. Is it clear now?
Yes, sir.
6.98, what I got. You have 6.976, right? So
Yes.
it should be 6.98. 6.98. If you take three significant figures, then multiplied by 10 to the power, let me, so it's coming. Check how much it's coming. Check. Monica, I did not give you the power yet.
Now it comes 10 to the power negative 07.
Yes. Negative minus 7,
07.
right? Minus 7 is
Yes,
coming,
sir.
isn't it?
Yes, sir.
10 to the power minus 7, and it should be like that. 6.98 into 10 to the power minus 7. So now your calculation is correct, because 3 by 4.3 is coming 0.698. Then it's coming 10 to the power minus 6. If you are taking one digit here left, it's coming 10 to the power minus 7. Is it clear how it's coming? Hmm? Monica? Monica and Falabi,
Yes,
are you
sir.
clear? Clear about this, what I'm saying? So 10 to the power minus 7, then our text for the answer, wavelength, so it should be meter, right? The unit of wavelength should be meter. So take this snap, take this snap,
Done, sir.
So it's done, right? You sent it, right?
Yes, sir.
Very good. Now we are done with this part. Let's go to the next. Here you go. Last part you see here what's written. Yeah, we have this page, last part. Can you read it? Where is Farabi? 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 Hello, Farabi.
Yes, sir.
Can you read this part B?
Yes, sir.
B. Part B, you read. Red light.
Yes, sir.
Read. Are you seeing the screen? From here you
Yes,
read.
sir.
B.
Red light from the laser strikes one side of a uh, glass prism at an angle of incident side. The light reflects towards the normal as it enters the prism.
So here we have red light, right?
Yes, sir.
And red light is also monochromatic, isn't it? That's why you see red light is not bending. Yeah, sorry, red light is not splitting. Is it clear? It's bending
Sir.
according to wavelength, it's bending, but it's not splitting. Is it clear?
Yes, sir.
Now state what happens to the speed of light as it enters the glass. What will happen to the speed of light if it is entering the glass? Speed will increase, decrease, or will be same? Hello.
Same.
If it is going,
Sir, it will be same.
you previously told if light goes from air to glass, it is decreasing.